Okay, till yesterday we discussed different Spark components, especially we gave special importance for Spark streaming because that is that much important. And the next rank goes to Spark ML. Okay, that is very important in our Spark. What generally, which is very tough and implement to do in the machine learning is, sorry, in MapReduce is machine learning. But because of Spark, that machine learning made easy and graph data processing is also very made easy. So don't neglect anything. How much the Spark core is important, on the same way the components of the Spark are that much important. Okay, so today I am entering into like the Spark core architecture. So here whiteboard, yeah, that core architecture I am taking. So how data is loaded, how it is executed, how distribution will happen, these things will be dealt by this architecture. See here, every time we are talking about for the past 3 days like RDDs. Simply here, RDD means resilient distributed data sets. So simply you can say Spark data objects are called RDDs. See how you have HDFS files in Hadoop. Similarly, the Spark has data objects called RDDs. See here, RDD is subdivided into partitions. That means your HDFS file is subdivided into blocks, right? Similarly, RDD is subdivided into partitions. So you can choose how many number of partitions you want for your RDD. Okay. See, these partitions will be distributed across different systems. This means different RAMs of different systems of the Spark cluster. I am writing the same statement. These RDDs, these partitions, you can say, are distributed across different worker nodes. That too in the worker nodes, not in the disk, into RAMs of Spark cluster. So that when some process or transformation is done, all these partitions will be executed parallelly. Okay. So that when transformation is done, transformation or some process, these partitions will be executed parallelly. So this is simply RDD. Like what kind of operations you can do on RDD? That thing we will discuss first. So we can perform like three types of operations. Actually high level if you talk, like you can perform only two operations. Two types of operations you can say. Two types of operations over RDD. So number one, transformations, and number two, actions. So what exactly the transformation and actions we will discuss now. If you talk about transformations, again three types. These transformations like operation over each element. Suppose there is a collection has some 10 elements. Suppose names, 10 names are there. Each name I want to convert it into uppercase. That is what some transformation. So operation over each element. And second thing is aggregated transformations. And third thing is filters. Aggregations means, like sum, average, grouping aggregation. Generally in SQL, group by aggregations we are giving, right? Same such kind of operations are called aggregated transformations. And in SQL, I don't want all the rows. Simply we are applying where and then we are giving some condition. Only the criteria matching records only will be fetched out. Similarly, my input is some log data. I don't want all the messages. I just want only error messages. So I will apply some filter to get only error messages. So equivalent to where clause, here we have filter. So these three comes under transformations. So to do these transformations, you have different functions. What exactly those functions we'll see later. So that example functions for transformations. Like map, flat map, reduce by key, which is for grouping aggregations, or group by key. In this way, different functions to perform the transformations. And even I want to apply the filter, filter is there. Filter by key, or filter by range, such kind of things. These things comes under the first part called transformations. And second activity is here, actions. The actions example, suppose already some transformed RDD is there. I want to apply how many number of records are there, count. And similarly, already RDD is there in the Spark cluster, which is already distributed into some 100 machines. I want to collect them into my client machine. Then collect is there. But if RDD size is bigger, I cannot collect all the Spark cluster data into my client machine because my client is not having that much of RAM to hold all these results. See, generally, like to test your results in SQL, what you are doing, no need to check all the rows. First 10 rows or 20 rows you will be checking. How to check the first 10 rows into the SQL? You are saying select star from some table name, limit to 10. The first 10 rows will be fetched. Okay. Similarly, here you have the function called take. Okay. So in this way, like suppose some RDD is there, I want to save the results into HDFS or some other file system. You have the function called save as text file. Even you can store into Parquet format, you can store into binary file like sequence format, like save as sequence file, save as Parquet file, save as text file. In this way, different things. All these things comes under actions only. Okay. Now, when transformations, when actions, these things, like let's continue the discussions. First we discuss like when these RDDs will be executed first. Later we see like how to define these RDDs. Okay. So when RDD will be executed is will be executed. This is the question. That means RDDs will not be executed when they are declared. And these will be executed. Here executed means these will be loaded into RAM and computed when action is performed. That means when you apply some action over RDD, then only the data flow will be executed. Okay. This kind of execution model, this kind of execution is called lazy evaluation. See, generally lazy evaluation is bad. It seems to be bad. In fact, for big data point of view, this is very good approach. Because today I declared one RDD, but I want to execute that into evening. As a developer, I just declared one RDD, but immediately I don't want to execute that flow. I want to execute that flow in the evening 9 p.m. Okay, just a minute. Yeah. So this kind of execution is called lazy evaluation. And I come back to that issue. What is the importance of lazy evaluation? Suppose if I declare one RDD, next after 2 hours I want this actually to execute it. If I declare immediately that RDD is loaded into RAM, means unnecessary it is occupying memory space, right? In this moment, if any other RDDs require some memory space, the space may not be sufficient. That's why whenever time comes, whenever it needs, then only the execution. Here the execution means loading into RAM and then computing. That will happen. Okay. So the lazy evaluation is recommended for big data. See now, and we discuss first what are the different ways how to declare your RDDs and how to create your RDDs. 3 ways to create your RDDs. So during this discussion, any question so you switch on your mic and ask me. There are 3 ways. Way number 1, 2, and 3. Observe this. The first one. When you parallelize your local object. Later, this is just high level headings I am giving you. Later we go for each heading. When you parallelize local object, one RDD will be created. And second way, when you perform some transformation over RDD, the result will also be RDD. Okay? When you perform transformation or filter over RDD, we get result set as RDD. Okay? This is second way. That means already think that one RDD existed. I perform some filter. Okay, my result will also be RDD now. This is second way. And third way, when you read data from file, the file can be HDFS or the file can be local or the file can be some AWS triple S file, S3 file, whatever it may be, depends on your cluster, in which cluster you are using Hadoop, that is important. When you read data from file using Spark context, simply the shortcut object for the Spark context is SC. Suppose here I am using Scala language for the Spark coding. Using Scala programming, if I read data from a file, RDD will not be created. If I read data using Spark context, then only RDD will be created. Okay, already we discussed. We have three types of, actually four types of contexts. Spark context, to work with the SQL's Spark SQL context, that means SQL context. To work with Hive tables, Hive context we have. Similarly, to work with the streaming data, we have streaming context. In this way, different context. But the base, everything, each context is inherited from Spark context only. Okay. So if I read data from file using Spark context, one more RDD will be created. Okay. These are the three different ways how to create your RDDs. Here created means up to now I am using the word called created. That's just the RDDs will be declared. Not yet executed. When these will be executed, when you perform action over these RDDs, then only the flow will be executed. Now for the previous screen, when RDDs will be executed, the three ways how to create RDDs we will see one by one. Observe this, all of you. This is Scala style of declaring an object. Some val I am saying x is equals to. Here I am taking a list collection 10, 20, 30, 40, 50. A simple collection I am taking with 5 elements. Now whenever I say the statement in Scala, now x object is created. Now this x is what? X is a local object or is a RDD, that means Spark object. Here this is a local object. Okay, it's not RDD. Here what do you mean by local means? I am submitting this statement from my client machine. The object which resides in our client, that is called local object. Okay, let me write that statement. The object which resides in client machine, because Spark cluster is some remote. Suppose my client is Bank of America, cluster is at California. Here from the client machine I am connecting to that machine, that cluster. But here whenever I said val x is equal to something, that is what simply my object, but this object is local object because presently this object is in my client machine. The object which resides in client. Okay, the object which resides in Spark cluster, that is RDD. Okay, like this. Now this is not RDD. I want to make this as RDD. How to make it as RDD? Just to try to understand. Once again I am repeating this x. Val x is equal to list of 10, 20, 30, 40, 50. Now this is local. Val y is equals to, I am saying that sc dot parallelize of this x. Now you are distributing this local object into Spark cluster. Now this y is RDD. Here x is local object. Okay, but now this y is having how many partitions? This y has one partition. Because our initial discussion, RDD is subdivided into partitions. Okay, it has one partition. If it is one partition, there is no question of parallelism. Okay, total partition is available in one single mission. When you run some query, that means when you run some process, that single mission has to participate in the execution. Okay, see, observe the same thing. Val z is equals to Once again I am going to parallelize the same X. SE dot. SE means here Spark context. Parallelize of X. I'm sorry. After X I am saying X comma 2. Now Z is what? Z is a RDD. And it has two partitions now. Suppose first partition like this. Partition 1 and partition 2. Partition 1 may have like a 10, 20, 30. The partition 2 may have like 40 and 50. Now this is in during execution. This will be available in system 1. This can be available in system 2. When I run some process, these two systems will be parallelly executing. Now if you have multiple partitions, what is the advantage of multiple partitions means? We can achieve parallelism. That is. So this is what the first meaning, the first way number 1, how to create RDD. What is the statement? When you parallelize local object, RDD will be created. So these are the examples for the first statement, way number 1. Okay, come to the way number 2. Another way to create your RDDs. Way 2. What is our statement for the headline for this way 2? When you perform transformation or filter over RDD. Here over RDD means that RDD is already existed. Okay, this is the second headline. Okay, now I am coming for the examples for this. Observe this. Val A is equals to, I am saying that a list of 10, 20, 30, 40, 50, 60. Totally 3 elements, 6 elements I am taking. Be clear here. Val B is equals to A dot filter of, here X represents each element. I am saying that X greater than 30. That means this is the statement similar to where class select star from table name where some column is greater than 30 on such way. Now B will be a list. What this list will be having? X greater than 30 means 40, 50, 60, right? Come on, 1 minute all of you. Please switch on mics and answer me. What is this? This is RDD or is a local object. RDD or local. Once again rethink because your answer is wrong.
Yeah,
Now it is a rethink means don't say local. Why it is not RDD on that way? Observe this. What is our headline? What is our headline? When you perform transformation or filter over RDD. Now I performed a filter. Is it RDD? A is RDD here?
no.
No. A is not RDD, right? A is a local, right? That means I performed my transformation or filter over local object so that I will get another local object.
Yeah.
Not the RDD. Okay? Okay, let me write clearly. Don't confuse that. Here, B is also a local object. Because we performed filter over local object. So that another local object will be returned. Okay, to understand you, to make you understand clear, one more example, rough example I am taking. Now this time I am expecting a right answer from you. Well, still some A is equals to List of same values I am taking 40, 50, 60. Val b is equals to a dot map. That means I am going to, whenever I said map means I am going to do something for each and every element. For each and every element I want to add 100. Here x represents each element. I am saying that x plus 100. That means for each element I want to add 100. So what will be the result first? 110, 120, 130, 140, 150, 160. Now tell me, what is this? This is a local or this is RTD? Now I performed a transformation. Is it a local? The B is a local or RDD?
RTD, sir.
మళ్ళీ తప్పు చెప్పారు బిడ్డ.
Local.
లోకల్ ఎందుకని?
The performing on
I am
A.
performing transformation on what,
Local
sir?
object. Local object.
మరి నేను ట్రాన్స్ఫర్మేషన్ లోకల్ మీద చేస్తే నాకేమొస్తుంది మళ్ళీ? If I
Another
perform
local object.
transformation on local, I will get another local object.
Yeah.
Okay. Here also this is local. Okay. I am writing that statement. Here, transformation is applied on local object. So here our local object is A. So that B will also be local object. Understand this? So that is this one. Now come back to our point. We are going to perform a transformation over or filter over RDD. Observe this. Well, some m is equals to list of 10, 20, 30, 40, 50. Val R1 is equals to SC dot parallelize of M. I am not saying any partition count means default number of partitions. 1. What is this M? What is this M
Local
here?
object.
Local. What is this R1
Local
now?
object.
R1.
RTD.
R1 is RTD.
RTD.
Okay. Yeah. Now observe this. Val R2 is equals to R1 dot filter. X is each element. I want X greater than 30. What is this now?
RTD.
RDD. ఎందుకని we performed our filter over another RDD, right? That's why return results will be RDD. Okay. And this is filter. I am going to apply the transformation. Just observe. Val R3 is equals to still R1 dot map. So here results will be 40, 50. I'm going to apply the transformation x plus 100. Now R3 will also be RDD because we applied our map transformation over existed RDD. That's why another RDD will be written. The results will be like this. The result is again a list. Okay. The list value, like for each element we are adding 100, so that you will get like 110, 120, 130, 140, 150 like this. Now what are all the locations during the computation? M is available in local, but R1, R2, R3, these will be into Spark cluster. Okay. This is second way of creating your RDD. And I am coming to the third way. So the headline is like this: when you read data from file using Spark context. Example for this, val some data is equals to, I'm saying that sc.text file. Some path I am giving, user my data. Suppose the file is some comment.txt. Now you are reading this one. Whenever you read data by using the Spark context, using some method, you will get RDD. Now again, if I perform some transformation over this data, another RDD will be getting like this. Now in this example, this data, it has one partition. That means has one partition for each block. For each unique block you can see. And think that this is HDFS file. Okay, later we go for the detailed discussion of the SC. Now, just a rough view. This is third way how to create. Suppose if I say like val my data is equals to, I'm giving the same statement sc.text file. The file is like this, user my data. The file is comment.txt. I'm not closing this. I'm saying that 3. Now each block is divided into 3 partitions. Each unique block. For each unique block, 3 partitions. During computation, all these partitions will be distributed into different slaves. That means different RAMs of different slaves. Now it's a small example. Suppose your file is comment.txt. Think that it has 10 blocks, 3 replicas. Total number of replicas now 30. But number of unique blocks are only 10, right? Again, each block is subdivided into 3 partitions. So that how many partitions? 10 into 3. Totally 30 partitions. These 30 partitions will be distributed into 30 different machines. The two location is RAM because our system is in-memory computing system.
Yeah.
Okay. These are the 3 different ways how to create your RDDs. Once again, I am summarizing. Okay, 3 ways to create RDD. Way number 1, when you parallelize local object. And way number 2, when you perform transformation or filter. And 3, when you read data using Spark context. When you read data from file using Spark context. So these are the 3 ways. Okay, now keep it in mind all the previous topics. Okay, today. These are the 3 statements for RDD. On RDD you can execute filter, you can execute transformation, and also you can execute actions. When this RDD flow will be executed is when action is performed. Okay, based on this, let's go for one simple example. Try to keep these 3 and the previous actions point, the lazy evaluation point. Okay, based on this, try to say answer to me. My statement is like this. Val some x is equals to a list 10, 20, 30, 40, 50, 60, 6 elements. I'm going to make it as RDD. let's say R1 is equals to X dot parallelize. So previously X is local, now I am going to parallelize. That means the return type is RDD. Parallelize of this X. Sorry, here don't say X, SC, right? SC dot parallelize. Parallelize of X. Val R2 is equals to. Now R1 is a RDD. R2 is equals to R1 dot map of X plus 100. Next val R3 is equals to R2. For R2 R1 input, for R3 R2 I am input because I am defining a flow. R2 dot again map. For each element what I am doing is I am squaring. You can say X cap 2 or X star X, simply the square you are doing. Val R4 is equals to R3 dot filter. Where X greater than this time 10,000. Okay, or let's say like 20,000 because each element will be selected. If you say 10,000, now 20,000, some filter I am applying. Now this is the thing, come on, answer me. Totally how many steps we have in this? 5 steps we have. Okay, what are all RDDs here
Yeah.
now? What are all RDDs now?
R1, R2,
R1
R3.
to R2, all these things RDDs, right? The first one is what?
Local object.
Local. Now you tell me, in our Spark cluster, what will be there in the RAM? Now what are there in the RAM? Not will be, what are there in the RAM?
RDDs are there in the RAM in
No.
our cluster.
Our first initial point మర్చిపోయారు మీరు. Our initial point you forget it. When RDDs will be executed?
When it is parallelized.
No. When RDDs are declared or created means when you parallelize. When RDDs will be
When you
executed, that is my statement.
Perform an action. After action.
When you perform action, right?
Yeah.
Up to now, I did not perform any action, right?
Yeah.
And that means what happened? Up to now, RDDs are declared, not yet executed. Just the RDDs are declared. R1 should take data from which one? R2. For R2 what should happen? For R3 what should happen? For R4 what should happen? This declaration in the form of a programmatic statements you have given. But these things are not yet loaded into your Spark cluster. Because our execution style is lazy evaluation. As per lazy evaluation, when action is triggered, that means when action is performed, then only the data flow will be executed. Okay, let me conclude this one. Now R1, R2, R3, R4 are just declared as RDDs. Not yet distributed into Spark cluster. Understand these points, sir, all of you? Not yet distributed into Spark clusters. So when this will be distributed? When I perform action, then only the flow will be executed. Here data flow is created with sequence of, let me write clearly. Here data flow is created with sequence of RDDs. That means you have different RDDs, R1, R2, R3, R4. When action is performed, When action is performed, then only flow will be executed. Data flow will be executed. During this flow execution, observe this point, sir. During this flow execution, RDDs will be loaded into RAM. Will be loaded into RAM and computed. Okay, I am coming back to the previous statement. What is our previous copy? X. Val X is equal to something. Some items. Val R1 is equal to SC dot parallelize. Now this is RDD. Val R2, for R2 R1 is input. Val R3, R2 input. Val R4. Clear statement I have mentioned previously. Now just like pseudocode I am writing. R3. Just input. Now this is the flow. Up to now, these things RDD's declaration. This is RDD declaration. Now no action is performed, right? I am saying that R4 dot count. Observe this. What is count? What is count? Map is a transformation. Flat map transformation. Filter, filter. Reduce by key is also a transformation. But count is action, right?
Yeah.
Yeah. Count is action. Now what will happen? Here count is action. See, you applied your action on R4. But R4 what is the input? R3. Again for R3 input is what? R2. For R2, R1. For R1 your local object. That means here this R1 is not taking input from any other RDD, right? This R1 is taking input from some local object. It is not taking data from any other RDD. This is called root RDD here. The R1 is root RDD. Now the flow execution starts from root RDD. Now flow execution starts from root RDD. This will happen when you apply action. Okay. What will happen during flow execution we will see. Now up to now clear, sir. If you up to now clear, then only you can understand next. Any question up to now? Any question? Any doubt?
No, sir.
Anybody?
Later here, sir. Actually, I don't understand that unit. What is the difference between unit block and RDD? Both are same.
It's not a unit block. Who is that, Sweta?
Yes, sir.
Yeah. ఇప్పుడు ఆల్రెడీ హడూప్ ఐడియా ఉంది కదండి మీకు. Okay,
Yes.
right. In Hadoop, like what is our storage? Okay, here the question asked by Sweta. Let me write. Otherwise, during this recording, you will be clear. And what is the difference between unique block? And RDD partition. Is it your question, Sweta?
Yes. Yes. Yes, sir.
Yeah. Yeah. Suppose, let me come to the next screen. Think that this is HDFS. These are the slaves. I have 4 slaves. Think that this is RAM of your slave. This is disk of your slave. RAM disk. RAM disk, RAM disk. Okay, this is slave 1, slave 2, slave 3, slave 4. Think that this is our master. Okay, for the processing of the master, in case of Hadoop, latest Hadoop, Yarn is the master. Yarn is the architecture. Within that, resource manager is the master. Okay, this is not the discussion like this one. Let's talk about HDFS. Suppose you have a file 1. Our latest block size 128 MB. Let's consider 64 MB block size for easy calculation. The file size is 100 MB. That means as per 64 MB, how many blocks? 62 blocks, right? You can say block 1, block 2. As per 3 replicas, how many replicas here? Let's consider 2 replicas. Default is 3. Now I configured it as 2. In this way, we can decrease the number of replicas and increase the number of. This is 2, this is 2. Totally now how many? 4.
4.
Now think that block 1, copy 1. Block 1, copy 2. Block 2, copy 1. Block 2, copy 2. EV blocks. Okay, na? Now, how many total replicas now?
2 replicas.
Total how many replicas?
1.
కాదండి మొత్తం కలిపి ఎన్ని మొత్తం ఇప్పుడు
Three.
ఫైల్ టోటల్ ఫైల్ 1 how many replicas it has 4 కదా
4.
even though 4 replicas uniqueness how many
2.
uniqueness is only 2 right
Yes.
Yes.
whenever I said val some d for data okay sc dot text file and if I say the path of the file 1 my file is file 1 think that complete path I am not writing just f1 I am saying now it has 2 partitions partition 1 in the cluster it will take this data partition 2 is into another machine it will take this data this partition comes under RDD D understand this point RDD name is D
Okay.
similar to your HDFS file our Spark execution is like will happen at memory right that means data to be loaded into memory right so it is taking data from those file blocks and loading into the partitions we have 2 unique blocks that's why 2 partitions only even though you have 4 replicas number of unique replicas are that means number of unique blocks are only 2 that's why only 2 partitions will happen understand this
Okay.
Sweta
Okay, sir. Yes, sir.
Yeah.
అర్థమైంది sir.
per minute yeah okay come back to the previous okay this is a question now all of you clear about this last statement whenever I said R4 is equal to R3 dot something it is not executed that is just declared but when you say R4 dot some count R4 dot some collect R4 dot some save as text file all these things are actions when you execute when you perform action then only the flow will be reset the flow execution will be started but now the question how this flow execution will happen okay this is the important especially the hardcore of your Spark execution model whenever I triggered the flow execution that means action performed what will happen internally this discussion we will understand suppose my flow is like this val r1 is equal to sc dot text file of some file val r2 r1 dot some map that means transformation I am doing val r3 r2 dot map some transformation val r4 Again R3 dot map some transformation. Why you are performing this many number of transformation is lot of things cannot be achieved by this single shot. Even in SQL also, just observe, to achieve our output, required output, one single select query is not enough. We are applying one select query, we are directing that select query output into another query. Again that query output is again directed to another query. Like subqueries we are writing, right? Similar kind of style. Okay. Now observe, the flow contains 4 steps here. Like R1 to R3, sorry, R2, R2 to R3, R2 to R4. This is what our data flow now. Now I am saying first time R4 dot count. All of you high concentrate please. That means action triggered. Come on, interact with me. We applied action over R4, right? But R4 cannot be directly executed because R4 input is from R3. Again come back to this R3. R3 input is from R2. R2 input is R1. R1 input is a file. That's why this is what root RDD. And based on this explanation, you tell me what is root RDD here? And how you define that root RDD? R4 is not root, R3 is not root.
For which the input is not RDD.
Yeah, exactly.
That is
Exactly. Okay, an RDD, a RDD which is not taking input from other RDD, that is what root RDD. Okay. So if you observe this R2, R3, R4, everything, each RDD is taking input from some other RDD. That is not root. Okay. So this is here root RDD. This R1 is root RDD. Whenever you perform action, the action will be triggered from root. So first time, up to now, this is just declared. First time R1 is going to be loaded. R1. Now here I am writing that steps actions. I said R4 dot count. Observe the execution steps. R1 loaded into RAM. Step 1 this is. Loaded into RAM. For some time, just think it in single system point of view. Actually, R1 means R1 may have 10 partitions. These loaded into RAMs of 10 different machines of the cluster. Okay. R1 loaded into RAM. See, this is root RDD. There is no computation required. And it waits for, it won't be removed. RDD is loaded. That means RDD is ready. Actually, when RDD is ready means when computation is performed. But for this is a root, right? For the root, there is no computation required here. Okay, and it waits for RDD to R2. That means it won't be removed immediately. Next step 2, observe it. R1 is ready. Once R1 is perfectly loaded, the step 2, R2 initiated, loaded into RAM. Then and starts reading data from, that means here initiated into RAM. Better word is here initiated. Initiated into RAM and starts reading from R1. And next computation will happen. What computation is done, whatever the logic you have given in the R1 dot map, whatever the expression you have given, that will be computed. Okay, computation is done. Once computation is done, R2 is ready. If R2 is ready, then what will happen is R1 will be removed from RAM. Because next onwards we don't want this R1. R1 will be removed from RAM. Then R2 will be waiting for R3. Up to now clear? Now step 2 is done. Come back to step 3. R3. Same process. Initiated in RAM. It can be same mission or it can be other slave mission. If it is distributed cluster, so many slave missions will be there. That's why the R3 can be loaded into other different mission. And takes input from, that means reads data from R2, because still R2 is waiting for this R3. Then computation will happen. That means R3 ready now. If R3 ready, what will happen? R2 will be removed from RAM. Then R3 will be waiting for R4. The final step, which is step 4. R4 initiated, reads from R3, then computation, because you applied again some other map transformation on the R4, that computation will happen, then R4 ready. Then immediately R3 will be removed. Now previously R3 is waiting for R4, right? Now R4 needs not to be waiting for anything, because this R4 is the last step of your data flow. Okay, then the action will be performed. What action? Count. In the results, how many records are there? It will be counting the action, because we said R4 dot count. Action will be executed on R3, executed on R4. Once results are collected, R4 will also be removed. From RAM. Okay. Once again, I am summarizing this entire explanation of this screen and this the next screen. Observe this. Our flow. R1, R2, R3, R4. You said first time R4 dot count. Come on, all of you. What will happen now? First R1 is ready. That means R1 here ready means is loaded and then computed. Okay. R1 ready. Then it is immediately will be removed or is waiting for the next one?
Waiting for R2.
Yes, waiting for next one. Okay, this is loaded, computed. Now R2 ready. Then R1 will be
R1 removed.
okay.
Sir, how it will know to remove R1?
Yeah, already. What is our execution model in the Spark? Who is taking care of all these things? Spark core engine, right? The Spark core engine is using DAG model. The core engine will keep monitoring all these things.
Okay.
Okay, and it will keep track of all this, and as per your declaration of the statements, it will keep all the things monitoring. Whenever the next RDD ready, automatically it will remove the previous one.
Okay.
Okay, automatically this will happen. There is no developer involvement in such process. Okay, now R1 is removed. Next, still R2 is waiting for R3. R3 loaded and then computed. Then R2 will be removed. Okay. Next, R4 loaded, computed. Then R3 will be removed. That means this is removed. Now who is there in the RAM? Only R4 is there in the RAM. On this, the count action is applied. Suppose the result is some 500. Once this result is collected, R4 will also be removed. After execution of this flow, who will be there in the RAM? After execution of this flow, who is there in the RAM? Nothing. Okay, again next time whenever I said like r4.com, entire flow has to be restarted. This
Yes.
will happen. But in this example, there is no concept called reusability. Okay. In our next class, I will go through the reusability. How exactly the reusability? There is a feature called persistence. Our major Sparks, when compared with the Pig is a data flow, Spark is a data flow. Both programming style is data flow. Then what is the difference between Pig data flow and Spark data flow? We discussed the day before class. Okay. I think not yesterday, before yesterday.
Monday.
What is the basic difference you can say between the Pig data flow and this data flow?
We can reuse those function, like instead of using the mapper repeatedly, we can define it and then use it.
అది కూడా అది పిగ్ లో కూడా ఉంది కదా ఆ ఫెసిలిటీ. దట్ ఫెసిలిటీ is already available in pig, but in pig observe you are reusing the code only,
Oh, yes.
not the transformed data. But already here R3 is already transformed. That R3 is required by some other RDD. No need to recompute that R3. Okay, here in Spark the beautiness is code reusability along with data transformation reusability. Okay, so how exactly this reusability will happen? What are, to do this, what are all the different options we have? Persistence and the different ways of persistence. This discussion tomorrow, we engage completely our discussion with the persistence feature of these RTTs. Understand up to now the flow execution?
Yes.
All of you?
Yes.
Yes, sir.
Yeah. Okay. I'm going to stop this recording. And please mail me, like after completion of this class I will send you this one. So up to now, like from whom I got email request, for all the people I sent you, I shared that video. Okay, so today also like to convert this into MP4 file. Okay, it may take another half an hour. Just after half an hour I will share you. Please mail me to me about this one. So put the subject as Spark class 4. Okay. Yeah. Thank you very much, all of you. And before closing, any questions, please? Any questions
Sir,
up to? Yeah, please. Who is speaking? Jagan?
Sir, Prashant, sir.
Yeah, Prashant, tell me.
Sir, one video is missing, sir.
అది సెకండ్ వీడియో కదా? సెకండ్ వీడియో రికార్డ్ చేయలేదు కదా, మర్చిపోయాం కదా.
ఓకే సార్.
ఆ రోజు మర్చిపోయాం, ఓన్లీ టెక్స్ట్ డాక్యుమెంట్ ఉంది. అది ఒకసారి నాకు మెయిల్ చేయండి, టెక్స్ట్ డాక్యుమెంట్ పంపిస్తాను. ఎప్పుడన్నా టైం దొరికితే ఆ సెకండ్ వీడియో నేను మళ్ళీ రికార్డింగ్ చేస్తాను.
ఓకే సార్.
ఓకే, ఆల్ ఆఫ్ యూ, థ్యాంక్ యూ.
Thank you, sir.
Thank you very much. Bye.
Thank you.
Thank you, sir.
Thank you.
Thank you.
Thank you. Thank you.